Hello students. So continuing with the last lecture where I was discussing about the 8085 instruction set. So moving ahead with the same topic, the next group in the 8085 instruction set that I'll be discussing is rotate group. So the first instruction in the rotate group is RLC instruction. What this instruction does, as we know, the accumulator in the 8085 microprocessor is a 8-bit register. So what RLC does, it rotates the content of the accumulator to the left by one position. So suppose as I have told you that accumulator is a 8-bit register. So let us suppose this is representing the content of the accumulator. This is also 8-bit, B0, B1, B2, B3, B4, B5, B6, B7. So this is the content of the accumulator. Now after execution of the instruction, what will happen, the content of the accumulator, each bit of the accumulator will rotate towards the left by one position. That is, B0 will come to B1, B1 will come to B2, B2 will come to B3 in this way, and the last bit B7 will go to carry flag, as well as B7 will go to the B0. Now for example, let's take an example. Let us suppose the content of the accumulator initially was 10111100. Now after execution of the instruction, RLC, what will happen? The content, each bit of the accumulator will move towards the left side, and will get 0 will move to this. So we'll get 0, 1, 1, 1, 0, 1, 1, 1, then 1, 0, 0, and 1. So this I'll get. So what is happening? Each bit has been moved towards the left side. Each bit is moving towards the left side, and the last B7 bit has moved to the 0, 1. Has moved towards the 0 position. So this B7 bit will also go to the carry flag. That is, carry flag will also get set. So what will happen? In RLC instruction, all the bits of the accumulator will move towards left by one bit. Now flags affected, obviously, as you can see, only the carry flag is getting affected, so the carry flag will only get affected. Now next number of bytes, as you can see, there is no hexadecimal number. Yes, there is no hexadecimal extra hexadecimal number mentioned along with this instruction. So the number of bytes is 1 byte, and that is representing the opcode of the instruction. Machine cycle, obviously it will need one machine cycle, that too for opcode fetch. That is, after fetching the opcode and decoding it, microprocessor will get to know that it has to rotate the contents of the accumulator, and since accumulator is present inside the microprocessor, so it does not need any extra memory read or memory write machine cycle, or input output read or input output write machine cycle. Means it does not need any extra machine cycle for the execution of the instruction. T states, obviously it needs one machine cycle, and that is opcode fetch, and opcode fetch has 4 T states, so all total 4 T states. Addressing mode, since this instruction is working on the content of the accumulator only, so the addressing mode will be implicit addressing mode. Next instruction is RRC. So RRC, it is just the opposite of RLC. What RRC instruction will do, it will rotate the content of accumulator towards the right bit by bit, and the last bit, that is B0 bit, will go to the carry flag, as well as it will come to the B7 bit. Now again, taking an example, suppose the accumulator content is 10110010. So after execution of the instruction RRC, what will happen? Each bit will go towards the right by one position. Each bit will go towards the right by one position. So the final result will be, accumulator will be 0 1 0 1 1 0 0 1, and carry flag status will be Since this B0 bit will go to the B7 bit as well as go to the carry flag, so the status of the carry flag will be 0. So this is how RRC instruction affects the accumulator content. Now since, as you can see, only the carry flag is getting affected, so flags affected, only carry flag will get affected. Number of bytes, no hexadecimal number mentioned along with this instruction, so number of bytes is 1. That is for opcode. Machine cycle, only one machine cycle will be needed because this instruction works on the content of the accumulator. So after opcode fetch, that is one machine cycle for fetching the opcode and decoding it, and after decoding, microprocessor will get to know that it has to rotate the content of the accumulator towards the right, and the accumulator is present inside the microprocessor, so it does not need any extra machine cycle to execute this instruction. So only one machine cycle, that is opcode fetch machine cycle, is sufficient for complete execution of this instruction. T states, obviously opcode fetch machine cycle has 4 T states, so the T states needed by this instruction will be 4 T states. Addressing mode, as this instruction works on the content of the accumulator only, so the addressing mode will be implicit addressing mode. Now next instruction, RAR. RAR instruction is same as RRC instruction, just a little bit modification is there. So RAR instruction, it also rotates the content of the accumulator bit by bit towards the right position. But here what is happening, the B0 0, that is the B0 bit, will go to the carry flag, and the carry flag status will go to the B7 bit, unlike RRC. In RRC, what was happening, the B0 was going to carry flag as well as B0 was coming to B7. But here what is happening, B0 will go to carry flag and carry flag's initial status will go to the B7. Now let's take an example. Suppose the accumulator content is 1011001 and the carry flag status is, let it be 1. So after execution of this instruction RAR, what will happen, each bit will go towards the right bit by bit. So ultimately and in B7 we will get 1, that is the status of the carry flag. So ultimately what is the answer, 11011010. So this is the content of the accumulator after execution of this instruction RAR, and the carry flag status will get improved and it will be 1 only, because here B0 is 1 only. Okay, again here only carry flag will get affected, as we can see in the instructions. So carry flag is getting affected, it's the only flag that will get affected due to this instruction. Machine cycle, obviously one machine cycle, first of all, number of bytes, as you can see there is no hexadecimal number mentioned along with this instruction, so number of bytes will be 1, and machine cycle, only one machine cycle, as and that too for opcode fetch, that is after fetching the opcode and decoding it, microprocessor will get to know that it has to rotate the content of the accumulator towards right bit by bit, and the accumulator is present inside the microprocessor, so it does not need any extra machine cycle for complete execution of the instructions, only one machine cycle, and that too for opcode fetch. T states, obviously opcode fetch machine cycle has 4 T states, so it will need only 4 T states. Addressing mode, since this instruction is working on the content of the accumulator, so addressing mode will be implicit addressing mode. Now next instruction is RAL. So the next instruction is RAL. The RAL instruction, it is similar to that of RLC instruction with a little bit difference. What is the difference? It also rotates the content of the accumulator. RL instruction also rotates the content of the accumulator bit by bit towards the left position, but here B7 bit will go to carry flag and the carry flag's original status will go to the B0 bit, unlike RLC. In RLC, what was happening? B7 was going to two locations. B7 was going to carry flag as well as it was going to B0, but here B7 is going to carry flag and carry flag original status is going to B0. Okay, flags affected, only carry flag will get affected. Number of bytes, as you can see, there is no hexadecimal number mentioned along with this instruction, so number of bytes will be 1. Machine cycle, obviously 1 machine cycle, and that too for opcode fetch. That is, after fetching the opcode and decoding it, microprocessor will get to know that it has to rotate the content of the accumulator bit by bit towards the left position, and since the accumulator is present inside the microprocessor, so it will need only 1 machine cycle for complete execution. It does not need any extra machine cycles. So T states, obviously, as it needs only 1 machine cycle, that is opcode fetch, and opcode fetch has 4 T states, so total T states will be 4 only. Addressing mode, as this instruction is working on the content of the accumulator, so the addressing mode will be implicit addressing mode. Now next instruction is JMP address. JMP is representing jump, and address is, you can mention any address. Suppose JMP, any address you can mention, suppose JMP C050H. So what this instruction will do, it will load the contents, it will load the program counter with the address given within the instruction and resume the program location from that from that location. Means if JMP C050H is given, so after execution of this instruction, what will happen? Program counter will get loaded with the address mentioned here, that is, it will get loaded with this address and the program will start getting executed from this address. As we know, program counter tells the microprocessor about the address from where the next instruction is going to get fetched. So JMP address, what it will do, it will load the program counter with a new address, and then the program execution will start from that new address. Flags affected, obviously no flags will get affected, as what is happening, only the address is getting loaded into the program counter. Number of bytes, 3 bytes of instruction, 1 for opcode and 2 bytes for the 16-bit address. As this address is of 16-bit, means 2 bytes are mentioned along with this instruction, so all total number of bytes will be 3, 1 for opcode and 2 bytes for the address. Machine cycle, obviously 3 machine cycles. First machine cycle will be used for fetching the opcode. After fetching the opcode and decoding it, microprocessor will get to know that it has to load the program counter with certain address, but it does not have the address, it has to read the address from the memory. So the second memory location will be used for reading the lower byte of the address, and the third machine cycle will be used for memory read, for reading the higher byte of the address. Once the address comes to the microprocessor will load that address into the program counter, and the program execution will start from that address loaded in the program counter. T states, obviously opcode fetch machine cycle, as we know, it has 4 T states, memory read has 3 T states and memory read has 3 T states, so all total 4 plus 3 plus 3, 10 T states. Addressing mode, as you can see, the address is working as an operand in this instruction. How? Because what this instruction does is it stores the address in the program counter. So what is the operand? The operand is the address only. So we can see the operand is directly mentioned in the instruction. Here the address is working as the operand, and the operand is directly mentioned in the instruction. So the addressing mode for this instruction will be immediate addressing mode. Now next instruction is J conditional address. J conditional address. So J conditional address is same as JMP address. The only difference is that it will get implemented only when the condition is true. Means, suppose here I have written the various formats for J conditional address. Suppose JZ C050H. So it is also a jump conditional address. This is the address, this is jump, and this is the condition that needs to be fulfilled. So JZ address, as I have written also, what does it mean? What is the condition? Jump to this address if the result is 0, only if the result is 0. So what will happen, what this instruction does, it will load the program counter with C050H only after it verifies the result is 0 or not. If the 0 flag is set, result is 0 means 0 flag will get set in the 8085 microprocessor. So if the 0 flag is set means the result is 0, means the condition is true, and then what will happen, program counter will get loaded with the address mentioned in the instruction. And if the condition is not true, then this instruction will not get implemented. Flags affected, obviously what is happening, only the address is getting loaded in the program counter after verifying the status of the flags. It is just verifying the status of the flags and determining the condition is true or not, and depending on that it is just loading the address in the program counter. So what is happening, only the address is being loaded in the program counter. So flags affected will be no flags will get affected, as only copying process is occurring here, only the address is getting copied and it is getting stored in the program counter. Now number of bytes, as you can see, J conditional address, 1 byte for opcode and 2 bytes for the address. This address is in hexadecimal number, and 2 bytes for the extra hexadecimal number, that is the address mentioned in the instruction. So all total how many bytes? 3 bytes. Now machine cycle, how many machine cycles are used? Now what will happen, first machine cycle will be used for opcode fetch. After fetching the opcode and decoding it, microprocessor will get to know that it has to verify certain condition, and if the condition is fulfilled, if it has to perform the read operation for reading the address, so that it can load the address in the program counter, because the address is present inside the memory. So it has to read the address, it has to perform memory read operation. So first machine cycle will be used for opcode fetch. After fetching and decoding it, second machine cycle will be used for reading the lower byte of the address. So in the meantime, microprocessor will also verify whether the condition is true or not. If the condition is true, then it will perform another machine cycle to read the higher byte of the address and store that address into the program counter. And if the condition is not true, then it will stop the process here only within 2 machine cycles, and it will not implement the instruction. So if the condition is true, we have 3 machine cycles. If the condition is not true, we have 2 machine cycles. So T states, obviously if the condition is true, we have 3 machine cycles, and opcode fetch has 4 T states, memory read has 3, and memory read has 3 T states, means 10 T states if the condition is true. And if the condition is not true, then we have 4 plus 3, that is 7 T states. Addressing mode, again here as you can see, J conditional address, here address is working as the operand, because it is what this instruction is doing, it is storing, or it is actually copying the address and storing it into the program counter. So here the address is working as the operand, and since the operand is directly mentioned in the instruction, so the addressing mode is immediate addressing mode. So up to this I'm ending this class, sir. We'll continue with the same topic, 8085 instruction set, in my next class also. So as I've told you, in this lecture I discussed about the rotate group, and the next JMP address and J conditional address, they fall under the branch group. So these were the 2 instructions that I discussed under the branch group. So I'm ending this class here. We'll continue with the next class. Thank you.